Welcome to the webinar. This morning, we will present out on Bonneville Power Administration's Custom Project Cost Documentation Guide. Welcome, everyone. So this is project overview. The project was sponsored by Bonneville Power Administration's Energy Efficient Management after a need was identified to improve the supporting documentation received on custom project submittals, specifically supporting cost data. Over the 14 years of Energy Smart Industrial's existence, an ESI custom project cost documentation guide was developed and revised through the work of BPA's Contract Officer Technical Reps, COTRs for short, our engineers and ESI staff. Much content from that guide was transferred to this new one with clarifications and enhancements, plus additional content developed in recent months applicable to custom projects for all sectors. This hierarchy shown here is reflected on the BPA Energy Efficiency public website. Thanks to Ming Koost and our EE marketing team for their quality work on this front, as well as their kindness and patience with me. My manager, Aaron Hope, and colleagues Kashmira McVeigh and Eric Boyer support me in a number of ways as I manage this project for BPA. Facility Energy Solutions, a small utility consulting firm specializing in measurement verification and retro-commissioning, was joined by SBW Consulting and Stillwater Energy, evaluation and SEM program experts, respectively, on this endeavor. This team is also revamping BPA's M&V library. Today we'll hear from Leah Webster and Santiago Rodriguez Anderson. Leah Webster from Facility Energy Solutions has over 20 years of experience in implementing energy efficiency projects and programs. She provides technical expertise in utility program implementation, measurement verification of savings, and commercial building systems. Santiago from SBW Consulting has 10 years of experience with modeling and verification for energy efficiency measures in applications ranging from high-performance residential buildings, data centers, wafer fabrication, to industrial processes. His experience includes conducting comprehensive commercial and industrial impact evaluations for BPA. I'd also like to acknowledge here the folks who've done a significant amount of earlier review and shared feedback of the draft guide. That'd be BPA, Energy Efficiency Engineers and COTRs. Also, Energy Smart Industrial, Steve Martin and Richard Jackson Gistelli. Thank you all so very much. This webinar will provide an overview of the newly developed guide. It's intended for developing, reviewing, and improving custom project proposals and completion reports. We will look at an overview of the document, and then step through the key elements in the document. This includes the type of custom projects and the types of costs required for each one, total or incremental. The various allowable project costs are detailed and acceptable documentation required to support energy efficiency project costs is defined. Additionally, project level cost components that are needed for cost effectiveness calculations, that is total resource cost, TRC, and submitted via BEATS. Take a look at the examples included in the appendix and discuss next steps, which include incorporating any feedback from this group and finalizing the cost guide. Leah, please take it away.
Thank you, Todd. As you mentioned, we are here to talk about the new cost documentation guide. This guide is intended to facilitate the approval of custom energy efficiency projects, although other types of projects such as UES and standard offer are included. The cost documentation provides guidance on the eligible costs for energy efficiency projects. It details the supporting documentation that is required to receive incentives. This similar data is used to determine cost effectiveness. It supports the BPA implementation manual, and as Todd was describing, it largely aligns with the ESI cost guideline, which at the time of this revision or this publication rather was at revision 13. This document is intended to supersede the ESI cost guidelines. And there's that draft cover page that you'll find. This is an overview of the document. You can see that there are 10 sections in the document, including 2 appendices, A and B. The first part of this document, sections 2 through 4, covers types of custom projects and types of costs, either total project costs or incremental project costs. Section 5, custom project cost components, details the allowable costs and documentation in each of 4 cost categories: new equipment and materials, used equipment, labor, and miscellaneous costs. Section 6, project implementation cost documentation requirements, details the required cost documentation for implementation costs. And then Section 7 and Section 8, operations and maintenance cost and non-energy impacts, are focused on the components used for the cost effectiveness calculations. And then the appendices include a number of examples. So we're going to walk through each of these sections and take a look at the salient content and hopefully save you a little bit of reading time. The first section is just an overview, and it provides context on why the BPA is collecting cost data and how this data is used by BPA. Specifically, cost data from projects is used to determine eligible incentives, and it's also used to evaluate the cost effectiveness of individual projects and programs. The data is collected through BPA's Energy Efficiency Tracking System, also called BEATS. This is not described in detail, but is cross-referenced for context. The second section describes the BPA process for custom projects, which requires cost documentation to be submitted at 2 stages in the custom project lifespan. You have the custom project proposal, or CPP, and then you have the custom project completion reports. And both of these require cost documentation, detailed data. For the custom project proposal, equipment and materials required to implement the energy efficiency project have not yet been purchased or installed, so estimated costs are expected. Sources for these estimates range from vendor quotes, which are relatively precise, to using general industry rules of thumb. At the completion report, however, the energy efficiency project has been implemented and actual costs are required. Invoices for materials and labor are needed along with other details such as internal customer costs if they are incurred. Where incremental costs are required, details on the baseline conditions and the baseline costs are needed as well. The incremental costs are detailed in Section 4. So Section 3 describes the different project types and the cost basis required for each. Custom project types in BPA include retrofit early replacement, retrofit replace on burnout, and new construction major renovation. As I mentioned, other project types like UES, standard measures, as well as strategic energy management measures are also included in the guide for full context. For each of these, the basis of the eligible costs is defined either as total project cost or incremental project costs. This slide shows a table from Section 3 of the Cost Documentation Guide, And what this table outlines is each type of program that you could have, the project type, subtypes that are possible within each. So within custom projects, you have retrofit early replacement, retrofit replace on burnout, new construction, major renovation. UES measures can cover both retrofit and new construction categories as well. Strategic energy management has its own category, and then similarly, specialty programs have their own program guidelines. And you'll notice here that the basis for implementation costs for an early replacement project is the total project costs, whereas the basis for implementation costs for retrofit and new construction projects are incremental project costs. Just to define these a little bit better, this information is also included in the M&V selection guide, which is being revamped as part of this project. But the custom project types, as we mentioned, are early replacement. And early replacement projects are where existing equipment or systems are functional, or where repairs can extend the life of the equipment beyond 1 year. These projects are implemented at least in part to achieve energy savings or energy efficiency improvements. Secondly, in the retrofit category, there's replace on burnout. This is where the equipment is at or near within 1 year or less of its useful life and repair is not reasonable. Therefore, these projects in this category are not optional, but would have to be done based on the equipment conditions. And then the third category of custom project is the new construction or major renovation, which is clearly when there is new construction required, expansion of facilities, or electrification of loads. Eligible project costs are covered in Chapter 4. Total project cost and incremental project cost are the two categories of project costs that are discussed in this section. It's in 4 categories generally. The total project cost include design, construction, new and used equipment, labor, and miscellaneous. Incremental project costs are included all of the same categories, but they are compared to a hypothetical baseline cost. So the same costs are collected for both the actual and for a hypothetical baseline, which is based on the code's requirements or the industry standard practice where there are no codes in place to set that requirement. We included an equation for those of you who that would help. It helps me. So incremental costs are total implementation costs less the hypothetical baseline costs. So it's the cost that was incurred to achieve the efficiency measure. One of the things that's very important about incremental cost is it is a one-to-one comparison between the baseline and the actual equipment installed. An example of a project using total project cost would be a project that includes installing a new higher efficiency fan with VFD controls, where an old single-speed ventilation fan was in place, was operating fine, could have continued to operate for the foreseeable future. This was deemed an early replacement of equipment because that fan was operational, and in part it was replaced to improve its efficiency and to add VFD controls. So in this case, total project costs are eligible, and the costs include the new equipment costs, including the fan, the VFD, the sensors, the controls, along with the installation costs of those components. An example of a project requiring incremental project costs is an end-of-life replacement of an air handling unit. The replacement is required because the equipment is at its end of life and repair is deemed infeasible, but the replacement includes adding a heat recovery wheel as an efficiency measure. In this case, the incremental costs are required since the project is replaced on burnout. The incremental costs are determined by comparing the actual project costs to the cost of installing an equivalent air handling unit without a heat recovery wheel. These incremental project costs are typically at least partially based on project bids that are gained during the design phase of a project. It is important when gaining bids on equipment to be installed that similar equipment without the energy efficiency components is gathered so that that incremental cost can be determined by the program. It's important that these are one-to-one comparisons. So the air handling units, for example, in this case, need to have the same features such as access panels and finishes, so that the only salient difference between the two is the energy efficiency measure, in this case, the heat wheel. Okay, so now we're up to Section 5, and Section 5 covers the allowable cost components. So these are the 4 categories that we've broken out, these project cost components. These are the same cost components that you're familiar with already seeing in the ESI guideline, and we've simply organized these into categories that made sense. New equipment and materials, used equipment, labor, and miscellaneous costs. And in this section, we go through and we look at both eligible and ineligible costs and documentation sources in each one of these project cost categories, so that there is clarity on what is in and what is out. And in general, everything that is a project expense is generally eligible and allowable in the BPA programs. It just simply needs to be well documented. So new equipment and materials, including invoices and estimates, both invoices for vendor installation, estimates on the baseline equipment, could be vendor quotes, a variety of other sources are perfectly acceptable as long as it's a viable and accurate estimate. Estimates are generally used for the baseline costs, as mentioned, so those are always estimates. You will never have an invoice for a baseline cost, so we will not be asking you for that. So this is new equipment. Used equipment, very similar. Cost to refurbish any used equipment would be included. Retrofit kits, shipping, freight, other costs to install used equipment is allowable. It simply needs to be well documented. The value of any used equipment should also be applicably devalued or discounted, or an estimate for a comparable item provided for context and price comparison. Contractor and customer labor. So not only contractor labor, but customer labor is eligible for qualification as a basis for supporting incentives. So that includes all the way from design through implementation. So any kind of project scoping, planning, design, permitting, that kind of line items are eligible. They just simply need to be supported with clear documentation. Measurement and verification activities, commissioning, as long as things are not paid directly by the program or paid by another BPA funded program, those would be ineligible. just to avoid double counting. Anything that is not directly related to implementation of the energy efficiency measure is not eligible. We want things that are directly applicable to the project at hand only included. This also includes miscellaneous costs. This is a big catch-all category, and you'll find permit fees, freight, rental equipment, sales tax where paid. If you don't pay sales tax, we'd appreciate not claiming those. Metering equipment that's used, any kind of demolition expenses, salvage value should be equally counted. If some funds were recovered from the old equipment, that should be claimed as a credit. Parts, standby parts that are required for backup system, if the backup is required and was in the original system, would be eligible. Ineligible items include maintenance contracts, any costs that would have been incurred regardless of the project, common parts generally used in maintenance like filters, and any additional features in the equipment that are not necessary for energy savings. So those are the 4 categories, and I know that was a really quick snapshot, but we wanted to go ahead and show you that level of detail so that you could get a good feel for the content of the document. I don't think there's any surprises in there. Almost all of those things were either mentioned or elsewise included in the ESI guidelines. The next section is section 6. And section 6 discusses the required cost documentation. And we've tried to break this down to be as simple as possible. We need a summary of the project costs, and we need those project costs documented. So those are the 2 things we need. Each item needs to have a supporting cost documentation. They need to be submitted at the project proposal and completion phase, as we mentioned earlier. The project costs need to include a project cost summary table. The summary table should list each type of each cost that is claimed, as well as the backup item submitted to support that cost. In addition, the project cost summary should include the project type, either an early replacement or replace on burnout new construction, the cost basis for the project. If you're calculating incremental project costs, clearly state that and provide a description of the baseline and a summary table listing all claim costs for one for the baseline and one for the actual, so that incremental project cost is very clear and easy to calculate. And then documenting each supporting cost with either an invoice or annotated detail as required. Calculations, spreadsheets, printouts are acceptable and just need to be labeled and cross-referenced so that it's as easy as possible for the BPA reviewer to make all the dots connect. This is a table that's included in section 6 of the project cost documentation guide, and this is an example that shows a list of each costs that are included in the total project costs in this case. This was an early replacement project of a heat pump water heater. So we have the heat pump water heater. We have miscellaneous hardware, wiring, contractor labor, internal labor, and disposal fees, all line items here with the documentation, supporting documentation type that is also submitted, clearly labeled, so cross-referencing is easy. We really want to see these numbers match up between the invoice referenced and the cost numbers listed here. And then we can just approve things very quickly. So this is just an example of what we'd like to see in the cost summary table. The next sections cover the cost-effective components as opposed to the project cost. These are auxiliary cost impacts, including changes in operations and maintenance costs. So changes in operation and maintenance costs are not eligible project costs, but they factor into a project's cost effectiveness and are important to document and are required to be submitted along with the project reporting in BEATS. So changes in operations and maintenance costs may include time or expertise required or the materials required to conduct the operations and maintenance compared to the baseline case. So cost impacts reported should be a change in the average annual operations and maintenance costs expected over the life of the measure. So if there's periodic costs, those would be averaged over the course of the life of the measure for reporting purposes. These changes in average annual cost are used in the TRC, total resource cost calculation, as part of the cost effectiveness calculations. So for example, if an HVAC system has pneumatic controls that are required frequent leak management and repair, and the controls are upgraded to a DDC system, eliminating that pneumatic system, the O&M benefits include the difference in the average annual maintenance costs, and there were significant reductions due to the elimination of the compressed air system. So these changes in operations and maintenance costs could be counted as an O&M benefit when filing the project in BEATS. So the cost reduction in customer O&M labor is an auxiliary impact that we want to capture and make sure is reported because it does add to the cost effectiveness of the overall project. Similarly, in Chapter 8, we cover non-energy impacts, or NEIs, that are also used in the project's cost effectiveness calculations. NEIs are also called non-energy benefits in some cases, but impacts is more accurate since they may be not always a benefit. These are direct impacts from the project and may include impacts to water, natural gas, or other non-metered fuel source. NEIs include items you won't find in any of the other categories, which are change in O&M costs, project implementation costs, electrical energy savings, and program administration costs. Note that electrical energy savings and program administration costs are reported by the utility and not reported in project level savings at the BEATS level. So an NEI, an example of a non-energy impact that might be claimed as part of a project is a new cooling tower was installed to provide a waterside economizer for a chilled water system serving the air conditioning. This new evaporative load creates a substantial increase in water consumption at the facility, and the cost for the makeup water lost through evaporation is a non-energy impact as a cost. We have several examples of cost effectiveness. Scratch that. We have several examples of cost documentation included in the guide, and my colleague Santiago is going to take you through those.
Thank you, Leah. So here in our presentation, we have an example that we can go over, and the guide has a number of others. So to begin with, in the guide, there are 6 examples included in Appendix A, which covers some typical scenarios. These are assembled from actual project examples with identifying information removed. Included are a project cost summary, determinations of total energy conservation measure costs in a large project, incremental cost calculations, as in how to find the incremental amounts of cost for a project, and other scenarios. It's of course not possible to cover all scenarios, but we think these examples are representative of what might exist out there in the energy savings cost reporting world. So let's move on to our next slide here, where we have an example covered. So this is a plant upgrade to install VFDs on motors instead of traditional starters. Because this project is considered a major renovation, the estimated incremental project costs were used. These were calculated as the cost difference between installing that variable frequency drive and installing that motor starter for each pump motor. And in this example, for the project proposal, cost estimates from Granger are used for both baseline and VFD scenarios. Let's move on to the next slide to see how this example plays out. So in the completion report, the actual VFD costs from the contractor and invoices are included. And the baseline costs estimates from the proposal are used so that the incremental costs can be calculated. So again, this is the difference between an energy efficiency measure and what a standard non-efficient measure would be, as is required for this type of new construction or new equipment project. And in a surprising turn of events, you can see that the total costs are actually less than expected. So this is what is reflected in the completion report. And here we have some further breakdown. Note that the 30 horsepower incremental cost information was not available or provided, but a customer service engineer did verify the installation of 4 motors during the post-project site visit. Instead of hassling people over requesting an updated table from the contractor, instead costs were estimated by interpolating 25 and 50 horsepower pumps to get the approximate cost for a 30 horsepower pump. It was agreed that the cost for the next smallest horsepower pump would be acceptable. That is, the incremental cost of a 25 horsepower VFD versus a motor with a standard starter was used for these 4 30 horsepower VFDs for this project. All right, and then moving on, we also note that self-certification of databases is a required piece of documentation if a end user is to submit SAP or similar accounting database extracts as part of their supporting materials. So in the guide, there is a sample end user self-certification, and this is what would allow continued use of those tracking software extracts. So I'll turn this over to Leah to cover our next steps. Thank you, Leah.
Thank you, Santiago. And that was our guide, all 10 sections. And the next steps, we hope that, again, you will download the draft guide and take a look and see if we've missed the mark anywhere, if it's could use additional clarification, or if it looks good. We want to hear that too. And if you could let Todd know by next week, that's actually a week and a half, that would be perfect, and that gives us enough time to get the final version out by the end of the year so that the cost documentation guide will be available next year for the 2024-2025 program year.